everyone. Now we're going to do the exercise number 3. First, we create a main class and then we create a subclass so that all the processes run inside it, keeping the main method clean and simple. We start by working on the subclass method so we can break down what is happening step by step. The main idea is to first store the data from user input and then reuse the data once the user chooses a sorted method. To this, we create a parent class named x3sorting, which handles storing the data, accepting input from the user, and print the array. We declare two protected variables so that the subclasses can access them. We have protected in R, an array to store the user numbers. Also, protected int size, the number of elements in array. Next, we create constructor to assign the values to this variable from a user input. In the constructor public x sorting scanner C, we first ask the user how many elements the array should contain. This value is stored in a size and used to create an array. Then a loop, gathering the individual number from a user until the slot in the array are filled. Another method print the array using array to string to make it readable, showing what user method. Here, we define the subclasses bubble sort that extend the superclass x sorting. By using extend, this class inherit an array and a size variable from the parent class, meaning we don't need to declare them again. The constructor public bubble sort calls super, which ensure the parent class constructor is executive first, properly setting up any data subclasses we need before running the bubble sort. The main logic in inside of the sort method, first, we declare the temporary integer variable temp to help swap values and boolean variables swap to check if any variable occurred during a pass. Bubble sort work by repeatedly comparing adjustment elements and swapping them if they are in the wrong order. The outer for loop run from I equals 0 up to size -1. Each pass to this loop represents one full sweep through the array, pushing the larger unsorted elements to its correct position, and the end of the array, just like how the bubble rises to the surface. Hence the number bubble sort. Inside this loop, we see swap equals false at the start of each pass to keep track of whether any swap happens. The inner for our loop run from j equals 0 up to size -i-1. That -1 ensure that with each pass we declare we don't recheck elements that are already sorted at the end. Inside this loop, we compare adjustment element rj and ri plus 1. If the current element is greater than the next, we perform a swap using a temp variable and then we swap equals true to indicate that a change was made during this pass. After the inner loop finish, we check if the swap is still false. If no swap were made during the entire pass, that means the array are already sorted. And we use break to exit early, which is make algorithm more efficiently because it avoid unnecessary passes. Next, we have here another subclass. We have the selection sort. Class extend the superclass x3sorting, which means it will inherit the array and the size variable defined in the parent class. Just like before, the constructor of public sorting class super, so that the parent class constructor run first the proper initialize of the array before sorting begins. The sorting process is implemented in the sort method. Selection sort works by repeatedly finding the smallest element in the unsorted part of the array and swapping it with the first element of the unsorted portion. Over time, this build a sorted section at the beginning of the array. The outer loop runs from I equals 0 to size minus 1 at the start of each loop. We assume that the current index I holds the smallest element in the assorted section, so we set min index equals I. The inner for a loop then begin at j equals I plus 1 and run through the rest of the array, checking if any elements of the smaller than the elements are min index. If a smaller element found, we update the min index to the index. After the inner loop complete, we have to find the index of the smallest element in the unsorted portion of the array. To put in the correct position, we swap the element at Ri with the element of R mindex. Then, ensure that after each outer loop iteration, the subarray from 0 to I is sorted. By the time the outer loop finishes, the entire array is sorted in ascending order. To keep the idea of selection sort is select the smallest element from the unsorted section each time and place it in the front. We have also the tree subclass, which is the insertion sort, which extend the parent class X sorting by extending the parent. This class automatically inherits the array and other properties, so we don't need to define them again. Inside the class, we first have the constructor that calls super, which simply means it's run to the constructor of the parents. This ensures that the array and everything set up in the parent class are properly initialized before we perform any sorting. The main logic from inside the sort method here, we use the for loop that start at index 1. Since the element of index 0 is already considered sorted on its own from each element in the array, we store its value in a variable called key, which act like the current item we want to insert into a correct position. Then we look back at the previous element using another variable g, starting from the index just before I. As long as the g is within bounds and the element at the position g is greater than the key, we keep shifting those larger elements one position to the right. This shifting creates an element space where the key can be placed. Once the correct spot is found, we insert the key back into the array at the position j plus 1. This process repeats every element as the result the array builds up in a sorted order step by step. By the end of the loop, the entire array is fully sorted. Now, finally, in the main method, we import scanner for user input and array for array operation. We display a menu of a sorting option using system out println. The menu is enclosed in a while loop so that if the user enters a valid choice, it repeats until the valid option selected. The user choice is stored in a choice and use the switch statement. We have case 1 bubble sort, case 2 selection sort, case 3 insertion sort. After executing the chosen sorting algorithm, the scanner is closed to release resources. This setup ensures the program handles input correctly, executed the selected sorting method, and display both original and sorted array clearly. And now, we're going to see the output of this exercise. We have here our parent class and the main class. Wait, let's see. Okay, going to choose bubble sort 1. We enter, we choose an array 4. We enter the array. We have 45, 23, 78, 90. And you can see here the current array 45, 23, 78, 90 that we enter. And then after the bubble sorting, we have here 23, 45, 78, 90. And another one. Okay, we choose selection sort, which is 2. And then we enter an array. Okay, size of an array 5. We have 67, 34, 78, 90, 83. Okay, the current array is 67, 73, 78, 90, 23 that we enter the 5 elements. After selection sorting, we have 23, 43, 67, 78, 90. And the last one, which is the insertion sort. Okay, we select insertion sort, which is 3. Okay, we enter the size of an array. We have, 4. Next, we enter an element. So, 23, 50, 15, 70, and 89. Okay. The current array is 23, 15, 70, 89, which is we enter. And then after insertion sorting, we have 15, 23, 70, 89. So that's all.